Welcome to Naradar Academy. In this video, I am going to explain how to find the solution of second order linear ordinary differential equations with constant coefficients. Okay, second order means the highest derivative is of order 2. Okay, linear means the unknown function y and its derivatives, all its derivatives dy by dx, d square y by dx square, everything is of power 1. Ordinary differential equation with constant coefficients. Constant coefficient means again the unknown function y, dy by dx, d square y by dx square. All the three have constant coefficients. Okay. See this equation, a d square y by dx square plus b dy by dx plus c y equal to capital X. Here this equation has the unknown function y, first order derivative dy by dx, second order derivative d square y by dx square. So this is the highest order. So this is a second order equation and this term is having power 1, dy by dx is also power 1, y is also of power 1. So all the terms, all the unknown function and its derivatives are all having degree 1. Therefore this is a linear equation and this a, b, c are the coefficients of d square y by dx square, dy by dx and y. So these coefficients are constants. So for such an equation, I am going to explain how to find the solution. This right hand side, you have capital X. This capital X is a function of X. So no y term should be there. It's purely a function of X. It can be anything, any function of X. So we are going to find out the solution for this particular type of equation. Now the general solution for this equation is given by means of two things. One is complementary function, another one is particular integral. So the general solution y is equal to complementary function plus particular integral. First let's see how to find the complementary function. So first let me write the given differential equation, a d square y by dx square plus b dy by dx plus cy equal to x. Now this d by dx is the differential operator. That operator we can write it as capital D. I am going to replace it by m. For finding the complementary function, just I am going to replace the operator by m. So this equation will become a into, instead of this d square by dx square, it will be m square plus b into this d by dx is m plus c into y equal to capital X. So what's the first step? Just you replace the operator, differential operator d by dx by m, and you take only the left hand side. For finding the complementary function, you have to take only the left hand side of the equation. No need to take the right hand side. So this is the left hand side, a m square plus bm plus c, and equate it to 0. Okay, for finding the complementary function, take the left hand side and equate it to 0. Now this is a quadratic equation. So solve this equation. Since this is the quadratic equation, it will have two roots, m1 and m2. So depending on the nature of this m1 and m2, we are going to write the complementary function. So three different cases arise here. The first case is both the roots are real numbers and they are equal. Okay. So what's the first case? Both the roots are real and equal. In that case, the complementary function is a plus bx into e power mx. What is this m? The root. Okay, the solution of this quadratic equation. This is the complementary function when the two roots are equal. The second case, the roots are real numbers but they are not equal. So two different real numbers if we get, in that case the complementary function is equal to a e power m1x plus b e power m2x. m1 is the first root and m2 is the second root. So this will be the complementary function in the case of real and distinct numbers. The third case is when you have complex numbers. When you have complex numbers as your roots, they must always occur in pairs. Pair means if one is alpha plus I beta, the other one will be its conjugate alpha minus I beta. Like this only the roots will appear. Okay, you will never have a single root as a complex number. Complex roots always occur in pair like this. So when you have like this, In that case, the complementary function is equal to e power alpha x into a cos beta x plus b sin beta x, where this alpha is the real part of the root and beta is the imaginary part. Okay. Now I have tabulated the different cases here. So when the roots are real and equal, m1 equal to m2 equal to m, in that case the complementary function is a plus bx into e power mx. When the roots are real and not equal, in that case the complementary function is a e power m1x plus b e power m2x. When the roots are complex conjugates, alpha plus I beta and alpha minus I beta, the complementary function is e power alpha x into a cos beta x plus b sin beta x. That's all. So now here I have discussed with the help of second order equation. That means d square y by dx square is the highest order derivative occurring in that. This procedure may be extended to any order, any higher order, that is for third order, fourth order, fifth order. There is no change for higher orders also. Okay, suppose if you have third order equation, then by replacing the operator by m, you will be having cubic root. So that cubic equation will have three roots, m1, m2, m3. If all the three are different, m1, m2, m3, all are equal, if m1, m2, m3 all are equal, in that case the complementary function is equal to a plus bx plus one more term you have to include, cx square. Okay, what's the term to be included here? A plus bx plus cx square into e power mx. There will be no change in this e. So here one more term you have to add, cx square. Right? So if we have three roots m1, m2, m3 and all are different. Okay, all are different. In that case, the complementary function will be a e power m1x plus b e power m2x plus c e power m3x. When you have complex conjugates, I already told you they occur only in pair. If one root is alpha plus I beta, the other root will be alpha minus I beta. So for cubic equation, two roots will be like this and the third root must be a what? Real number. So after writing this for the two roots, third root must be a real number. For that you have to include one more term, c e power m3x. Okay. Here this a b we have written no, these a b are called arbitrary constants. So how many arbitrary constants occur in the solution of a differential equation? That's an important question. The number of arbitrary constants in the solution of any differential equation is equal to order of the equation. Okay, that is for polynomials we used to say no, if it's a quadratic polynomial it will have two solution. If it's a cubic polynomial, three solution. If it's a fourth degree polynomial, four solution. In that same way for differential equation, if it's a first order differential equation, number of arbitrary constants is equal to 1. Second order equation, number of arbitrary constants is equal to 2. Third order equation, number of arbitrary constants is equal to 3. And so on. Okay, this is the way we associate the solution with the order of the equation. Okay, so the complementary function part is over. Next we are going to see how to find the particular integral. So for finding the particular integral, we are going to take the entire equation. So the particular integral is depending on the right hand side of the given differential equation. Suppose the right hand side is of the form e power alpha x. This is the first case. The particular integral is equal to 1 by, what is this equation? A d square plus bd plus c into e power alpha x. So this step is common for all the cases. 1 by, you write the left hand side a d square plus bd plus c into e power alpha x. When you have the right hand side as e power alpha x, the substitution is we have to replace d by alpha. So this will be 1 by a alpha square plus b alpha plus c. Simplify and write it as the solution. That will be the particular integral. Sometimes when you replace this d by alpha, you may get 0 in the denominator. So what to do? In that particular case, if you are getting 0 in the denominator, look at the factors of this equation. The factors already you have obtained while finding the complementary function. No, look at the factors. If the factors are equal, okay, if the factors are equal, m1 equal to m2 equal to alpha, in that particular case, no need to do any calculation. Directly you can write particular integral is equal to x square by 2 into e power alpha x. No need to do any calculation at all. Suppose if this equation has two different roots, one is alpha, the another one is m2 which is not equal to alpha, then the particular integral is 1 by a into m1 minus m2 x e power alpha x. So this is when the equation has two different roots. One is equal to alpha, the another one is different from alpha. So this is the second case when the right hand side is of the form either cos alpha x or sin alpha x. So how do we write the particular integral? 1 by a d square plus bd plus c into the function, whether it may be cos alpha x or sin alpha x. Here the replacement is d square has to be replaced by minus alpha square. Okay, there is no substitution for d. You have to keep d as it is. Only d square has to be replaced by minus alpha square, and after that we have to do some calculations. Okay, that will explain while doing the problems. So as of now, just you remember, when you have either cos alpha x or sin alpha x, in that case the replacement is d square is equal to minus alpha square. Here also, while doing the substitution, you may get 0 in the denominator. In that case, look at the right hand side. If it is sin alpha x, directly you write the particular integral equal to minus x cos alpha x by 2 alpha. If the right hand side is cos alpha x, write the particular integral equal to x sin alpha x by 2 alpha. No need to do any calculations when you get 0 in the denominator. Directly you can write them depending on the right hand side. Okay, right. Then the next case is right hand side is of the form x power m. That is any integral powers of x. In that case, you have to rewrite this denominator. Rewrite this denominator in the form 1 plus something. Okay, that is, here we have a d square plus bd plus c. No, you take this constant c outside, so that equation will be in the form 1 plus something, and bring it to the numerator and use the binomial expansion and do it. Okay, while doing the problem you can understand. So for x power m, what we are doing, rewriting the denominator in the form 1 plus something. Okay, that's all. Here you will never get 0 in the denominator. Okay, then the final case is the right hand side is of the form e power alpha x into capital X, where this capital X can be any of the previous cases that already discussed. That is, either it may be x power m, or it may be sin alpha x, or it may be cos alpha x. Here the particular integral is obtained in two steps. The first step, we are going to eliminate this e power alpha x. For eliminating this, we are going to replace this d by d plus alpha. Okay, for eliminating this e power alpha x, do the replacement d as d plus alpha and keep this e power alpha x in the front. It won't be there. Okay, so because d is a differential operator, no, so once you do this substitution, this e power alpha x will be brought before the term. You should not keep it here, otherwise you will be wrong. Okay, so do the replacement 1 by a into d plus alpha the whole square, b into d plus alpha. This is not d. Okay, this is d plus alpha. D plus alpha plus c into x. Then do the simplification. After that, depending on the nature of this x, already I told you, no, this x may be either what, x power m, or sin alpha x, or cos alpha x. So depending on its nature, you have to proceed. Okay, here I have tabulated everything for particular integral. So the first case is right hand side is of the form e power alpha x. The particular integral is 1 by a d square plus bd plus c e power alpha x. What's the replacement? D is replaced by alpha. Suppose while doing this replacement, you may get 0. In that case, look at the solution of this equation that you already found out in the complementary function. If they are equal, the roots are equal, then the particular integral is directly you can write it as x square by 2 e power alpha x. if they have two different roots, one is alpha, the another one is not equal to alpha. In that case, the particular integral is equal to 1 by a into m1 minus m2 x e power alpha x. Just you remember this x e power alpha x, that's enough. Here x square by 2 e power alpha x, here x e power alpha x. The other things you can do by calculation. Just you remember, when only one root is equal to alpha, the particular integral is x e power alpha x. When two roots are equal, what? X square by 2 e power alpha x. So this is when you get 0 in the denominator. Otherwise, no need to come here. You can finish with this one alone. The second case is right hand side is of the form either cos alpha x or sin alpha x. In that case, the replacement is d square is equal to minus alpha square. So minus a alpha square plus bd plus c. You should not do anything for this d. Okay, that has to be simplified in the next step. That we'll do while doing the problems. So even for substituting this d square equal to minus alpha square, we may get 0 in the denominator. So while you get 0, this is the substitution. So when the right hand side is cos alpha x, the particular integral is x sin alpha x by 2 alpha. When the right hand side is sin alpha x, the particular integral is minus x cos alpha x by 2 alpha. No need to go for any calculation. Okay, that's all. Then the third case is the right hand side is of the form x power m. In that case, what we are doing, rewrite the denominator in the form 1 plus something, bring it to the numerator, write the expansion using binomial series, and then you do the calculation. Here you will never get 0 in the denominator. Okay, then the last final case is the right hand side is a combination of e power alpha x and x, where this capital X can be x power m or sin alpha x or cos alpha x. For this, we do the particular integral in two steps. The first step is removing this e power alpha x. For its removal, what's the replacement? Replace d by d plus alpha. So after that, you have to keep this term in the front. You should not write it here. So after this replacement, do some simplification. After that, depending on the nature of this x can be x power m or sin alpha x or cos alpha x, no. So depending on the nature, you can proceed. Here also, you will never get 0 in the denominator for this e power alpha x. Suppose with this term, you may get 0. For that, you have to follow the previous procedure. Okay. So that's all. So these are the different cases that arise in the particular integral. So after finding the complementary function and particular integral, you have to write the general solution as y equal to complementary function plus particular integral. And the important thing to be remembered here is order of the differential equation is always equal to number of arbitrary constants in the general solution. So where do this arbitrary constant exist? In the complementary function. If it is second order equation, 2 arbitrary constants. If it is third order equation, 3 arbitrary constants. So if it's, and so on. So this is the general procedure for finding the solution of a differential equation. We'll do some problems in the next video. Okay, thank you.